Average atomic masses. See, every element has certain isotopes associated with it. We know that every element is having isotopes, and their percentage abundance on the nature differs from element to element. Now, if we are picking up any particular element from the nature, definitely we will be having not only of one type of its atoms in it in that particular sample, we will be having all the different types of atoms, which are what we can call the atoms of its isotopes in that particular sample. So what will happen is, then therefore, the mass of that particular sample cannot be taken on account of a certain one type of an isotope. It has to be the average of whatever the number of isotopes that are present or existing in that particular sample. Like I can give you an example, like we know that chlorine. We know that chlorine has one isotope, chlorine 35, and it has also a chlorine 37. So we have two isotopes of chlorine which naturally are existing in the nature. And if we randomly picks up any sample of a chlorine, we know that that sample will be having certainly many atoms of chlorine 35 and of chlorine 37 also. Now, if we take the mass of that particular sample as 35, that will not be correct, because it will be certainly more than this, because there are certain atoms which are of chlorine 37 which will be increasing its mass. Simultaneously, we will be having chlorine. We cannot take the mass of the sample as 37 because all of them are not of 37. Certainly the mass is less than 37. So what is the option left is? We have to take the average of, the atomic masses of whatever the number of isotopes or what are the different types of isotopes we have for that particular element in the sample. Now let us see how we can do this, and remember that the mass which we get after taking the average is called the average atomic mass, and it is the mass which should be used in all our calculations, because that is actually the practically correct atomic mass for that particular sample. In our general language or in general our words, we can say that like normal carbon is having 12 atomic mass, nitrogen is having 14, or hydrogen is having 1. But for a precise, accurate calculations, whenever we are involving the masses, we need to take which mass? It is the average atomic mass, because that will be going to give us the exact answer. Now let us see how to find out this average atomic mass. For this, we need to know the percentage abundance of these isotopes on the Earth's crust. Like for this chlorine 35, we know that it is 75%, and chlorine 37 is 25%. What does this percentage abundance means? If we randomly picks up 100 atoms of chlorine from any sample in the nature, we will find on an average 75 will be of the chlorine 35 and 25 will be of chlorine 37. Now therefore, we have to take the average to find out the average atomic mass. So how average atomic mass is taken? See, what we do is we simply multiply the 75 or 35 with the 75, because we know that there are 75 atoms out of 100 which are having atomic mass 35, and we will be multiplying 25 with 37, because we know that practically there are 25 atoms which are having atomic mass 37, and total the atoms we are having is 100, so it divided by 100. The answer we get is 35.5. So this is how 35.5, again in terms of U unified mass, is the average atomic mass of the chlorine element, the atoms of the chlorine atom. So this is how we are able to find out the average atomic masses. Let me give you an example, one more example. Like suppose in a sample it was found that carbon 12 is 90% and the rest is C14. Find the average atomic mass of carbon. How we can find out the average atomic mass of carbon in such a case? See, we know that C12 has been given to us, its percentage abundance is 90%, C14 is 10%. So the average atomic mass will be 90 into 12 plus 10 into 14 by 100. So it will be 1080, 140 by 100. So it will come out to be 1220 by 100. So it will be 12.2. So this 12.2 will be the average atomic mass of this chlorine sample which is taken as per this numerical. So this is how we find the average atomic mass.